Okay, so the first thing I want to do is lines. This is something that you have seen before, okay? And you have two versions or two formulas. This is called the Points law formula, and this is called the y-intercept. Both of them require to find the slope, and to find the slope, remember the formula is y2 minus y1 over x2 minus x1, which here requires that you get obviously two points. This is the formula you're going to use every time they ask you to find the equation of the line, which is something you're going to use in calculus 1, calculus 2, all the time. I mean, a lot of times here too. If you simplify this, you end up with this formula. So therefore, y equals to mx plus b is a special case of this one. So this is the main formula. If you simplify this, then you get this one, okay? In order to use this formula, you need 1 point, which is always given. This point is always given. And if they don't give you the slope, they have to give you 2 points or something else to find the slope. But once you find the slope and the point, just plug it in, simplifying, you get this, okay? So we're gonna use this formula like 4 times right now, and you'll see. It's gonna be this same formula, and you're gonna give you 2 points. For example, here is the first case of that. It says find the equation of the line. So since it says the equation of the line, that automatically implies this formula. And they give you 2 points. So what are the 2 points? x1, y1, and x2, y2. By the way, you can reverse the order and you still get the same answer, but to make things easier, just keep it as 1 and 2. Okay, so with those 2 points, we can find the slope. So the slope is 6 minus 4 over 4 minus 3, which will give you, what is it on the top? 2. And on the bottom, that's not correct. So on the bottom, this should be what? 6 minus 1? So 6 minus 4 and then 6 minus 3. Okay? So therefore on the bottom it should be 2, this is 3. Okay, so that's the slope. Then if we use the equation, remember y minus y1 equals to m x minus x1. Well, y1 is 4 and m is 2/3. That's the one we just found. And this is x minus 3. So we're using this point. If you use this point, you will get the same answer, but just go with the first one. Then this 3 view. So you have y minus 4 equals to 2/3 x. If you multiply 2/3 times 3, notice that this will cancel, and you'll end up with just minus 2. And then add 4 to each side, and from here you get 2/3 x plus 2. And notice now this is in this y-intercept form. This is the slope, and this is the y-intercept. So you start here, which means you start in this one, and you end up with this. Every time you simplify this, you end up with this form. Something you have to be very aware is that there is a big connection always between geometry and algebra. This is what I mean. Look, just pretend that you haven't done any of this, okay? That we didn't do any of this. And you have the points, and you plug in the points. So the first one is 3, 4, which is right there. And the second one is 6, 6, okay? So just pretend we haven't done any of the other stuff. From here, you can make a straight line. Okay. And notice that the y-intercept is 2, by doing that. So from here, it's telling you b is equals to 2. And between these 2 points, you can make a triangle. Remember the rise over run stuff for the slope. This is 2, this is 3. Since it's going up, these two imply that the slope is 2 over 3. So therefore, you could just use the graph and say that this is 2 over 3x plus 2. And notice it's exactly the same thing, just using the graph. Now, sometimes you may not be able to use the graph, but it is important that you make the connection between the two. So the 2 points you have is, once you do the problem, is 0 and 4,000, right? And the other point is what? 4 and 200. Okay? Yes, no? So then you need to find the slope first, which will be 200 minus 4,000 divided by 4 minus 0. And this is minus 950 once you simplify. Is that okay? So far so good? All right, so again, we're going to use the same formula. Remember, y minus y1 equals to mx minus x1. The only difference is you're going to change the y for b and the x for t, but it's the same formula. So therefore, you're going to have b minus y1, which is 4,000, equals to the slope, which is minus 950, and then t minus 0. So then this will be v minus 4,000 equals to minus 950t, because if you distribute, you get 0 there. And then if you simplify, you get this in the slope-intercept form. So that's the equation. Okay, same thing we did before. So now from here, it should be obvious. What is the slope? Is minus 950. What does that mean in this case? What does the slope of minus 950 mean? What is it? It's going down by what? 950 every year. That's it. Okay. And what about the y-intercept? Is 4,000, which means what? Originally, at time 0, the computer was worth $4,000. Okay? So if we do the graph, these are the 2 points. The first one is 4,000, and when this is 4, this is like 200. And you can see that this is going down. I mean, that's not the best line, but okay, it's going down. If this was not a word problem, okay, the line could keep going forever, and it could keep it going forever here, okay? In this particular case, and this is something else that you have to be aware for math, you have to use a lot of common sense, okay? In this particular case, you technically had to stop here. There is no point of going any farther. Why? So, therefore, it makes no sense to go over this. I mean, to go past this point, because then the price becomes negative, and you're not gonna sell something for a negative value, because that means you had to give the computer and you had to pay them too, which, unless you work on the government, I don't see how that's possible. Okay? All right. Now, the next question is, well, for how long will the computer be worth more than $2,000? So remember, this represents the price. Okay? This was the price of any time, time t, as long as you don't go over this. So therefore, if we go here, you want minus 950t plus 4,000 to be equals to 2,000. That's what this is asking you. So if you solve for t, this will be minus 2,000. How do I get minus 2,000? Well, subtract 4,000 from both sides, and then divide by minus 950. Now, since this one says more than, how do you write that mathematically, more than? It will be this inequality, right? Does anybody remember from your past lives what happens when you divide by a negative value for inequality? You have to flip the direction, okay? So therefore, in this case, t will be less then I think this is 2.1 something, so use the calculator. Okay? So as long as the computer is less than 2.1 years old, the computer will be more than $2,000, which you can tell that from here. Like, you look to the graph, 2,000 is here. At this point, the computer is more than $2,000, and at this point is less. So you could just solve that from the graph too. That's why I told you should make always connections between the graph and the equations. What to do on the next page is something called piecewise functions, but it's essentially multiple lines like this, okay? So a piecewise will be something that looks like this. You have a line, then you have one line here, a line here, a line here, but all of them are going to use the same equation, and it's called piecewise because you have several pieces. And this example is actually pretty good to explain the whole thing, okay? So here it is. Look, you have a cell phone plan that costs $39 a month, okay? The plan includes 2 gigabytes of free data, and it will charge you 15 gigabytes for additional data you use, okay? This is a very realistic problem, okay? So now, the question says, construct a model for the monthly cost of the plan if the buyer uses X gigabytes. So X could be any amount, okay? So this is the part you have to be careful of. This has 2 pieces. The first piece says that if you use 2 or less, you have to pay $39, okay? Which is what you have. Now, what will happen if you get a cell phone plan and you only use 1 gigabyte? How much do you have to pay? What do you think? If you only use 1 gigabyte, you still have to pay $39 because the plan is for a month. Whether you use 2 or less, you still have to pay that. What about if you use no data whatsoever? You still have to pay $39. Like all the people that they say they're going to lose 5,000 pounds on January for New Year's, they get a gym membership and never use it. Well, you still have to pay for it, right? Same thing. Now, what about then if you use 3 gigabytes of data? That routine changes because you had to pay $39 for the first 2 plus 15 for the extra 1, okay? So this is how you do this problem the easy way, like, because some people have issues with this. Just go to the extreme, and by the extreme I mean this. If you use 2 gigabytes of data, right? So you use 2, you have to pay $39. That's the first point. Remember, you need 2 points to do what we're doing here. If you use 3, then you're gonna pay what? 39 plus 15, which is 54. So then the second point will be 3 and 54. So just go to the next one. There is no need to go to 10, 20, or whatever. Just go to the next value after the endpoint. From here, you find the slope, which obviously has to be 15, but you should just check that it's 15. Is 54 minus 39 over 3 minus 2. So this is 15 over 1, which is 15. Because after 2, you're going to pay 15 for each, okay? But this is the part where people get very confused, but this is pretty simple. So here it is. So therefore, the cost is going to be like this. Look, you're going to pay $39 whether you use nothing or 2 gigabytes of data. After that point, you have to pay $39. Okay. Now after that, and this is the part where people mess this equation. Okay. So if you just use the formula we just used right now, twice already, it should solve the problem. So since it's asking you for the equation of the line, and you have 2 points, these are the 2 points, all you have to do is use the 2 points. You already find the slope, okay? So therefore, remember the formula was this. Let me write it one more time. Y minus y1 equals to mx minus x1, okay? The same equation that we used twice already. What is y1? 39, right? This is y1, this is x1. What is the slope? The slope is 15 x minus 2. And then simplify. This is 15x minus 30, add 39 to both sides, and this simplifies as 15x plus 9. And this is the second equation. So this will be 15x plus 9 as long as x is more than 2. Okay? You should always check that this works, okay? What happens if you plug in 3 in here? How much is 15 times 3? 45 plus 9 is 54. So that's how you know this works, okay? This is usually the part that people always miss, but you can see this is pretty straightforward. And then the graph, well, we did the first part already. We already did this. The 39 is this. And then after that, this is going to go up like this. I mean, that's not precise, but it's going to go up like this. And that's it. Okay? Now, what is the difference between f of x and y? Well, there is really no difference. It's exactly the same thing. This is you when you go to buy hot dogs, and this when you go to a fancy restaurant. It's still you, the same thing. It's just how it's written, okay? So now what this means essentially is what is the value of y when this x value is given? That's what it means. So for example, here it says, what is the cost if you use 0.5 gigabytes? Well, what will be the cost if you use 0.5 gigabytes? What is it? 39, right? So what would be the cost if you use 2 gigabytes? 39. But what would be the cost if you use 4.5 gigabytes? Then you need this equation, right? So it will be 15 times 4.5 plus 9. And whatever that is, that's the cost. All right, so here is the problem. So this is one equation. So use the same equation we've been using. You don't really need it for this one, but you need it for this part. And just combine the two into a single function. Okay, just try that for like 4 minutes. All right, so let's check. So this is the easiest one, okay, this part. Because it's just a straight line. So this is like the 39 for the previous one. So therefore, what will that part will be? So f of x is going to be, what value is that? 5, right? And that's true only from where to where? From 4 to 7, okay? So this is 4 less than equals to x less than 7. By the way, another thing, that every time that I write notes somewhere, that means this is something you're supposed to remember from the past. So you should really write this down. So here it is. If you have this or this, you can use either wholes or you can use parentheses. If you have this or this, you can use closed circles or brackets, okay? Because we're gonna need this a lot. In calculus, they only use this, but for now, until you get used to it, it's okay to use this. So therefore, since this is open, that means it has to have the equal sign. They cannot have the equal sign, that's all, okay? But now, what about for this one? Notice what is the slope of this line? What is it? This is 2, right? And this is also 2. So therefore, the slope for that line is 2 over 2, which is what? 1. And then, what is this point? That's the point 1, 2, right? So this one is the point 1, 2. So therefore, you have the slope, and you have the y and 1 point. So therefore, you can just use the equation that we use now three times, okay? Same equation. Let me write it one more time. And all you have to do is plug in the point. This is y minus 2 equals to m times x minus 1. So then y minus 2 equals to x minus 1. And then you add 2. This will give you y equals to x plus 1. And therefore, this will be the second equation, just x plus 1. You don't write the y, because remember y and f of x is the same thing. And this is true between 1 and 3. Okay. By the way, these values are also going to be called the domain, which is what we're going to talk about next. All right, any questions on that? The domain, if you have a graph, is very easy to tell. The problem is when you don't have a graph. So you have a graph, the domain clearly is the area from here to here, or the how far you can go from left to right. So this one goes from 0 all the way to 7, and that's the domain. It's pretty simple. If you have a arrow, this will keep going forever, so it goes to infinity. Okay? So therefore, in that sense, the domain is pretty simple if you have a function. By the way, how do you know if something is a function? It passes the vertical line test, which means it crosses the graph only once. So therefore, this is a function, and every function has domain, which is what we're going to focus on right now, and range. So that's a pretty bad way to write range. In a very simplistic way, you can say domain are the x values and range are the y values. But again, the x values that you are allowed to use, that's the key part, okay? So to make life easy for you, there's two important notes, look, that you need to worry about domain, and this will help you a lot. There are two things you cannot do, and those are the things you should worry about. You cannot divide by 0. Just remember that forever and ever. You cannot divide by 0. And also you cannot square root negative values. So these are the two things you have to watch out for. If you don't do these two, then the domain will be everything, okay? And you'll see what I mean in a second. And also, there is several ways in which you write the domain. I'll show you all of them right now. And depending on the situation, it's better than the other one. But let's start with a simple example right here, look. If you look to this one, when will this be 0? If x is what? What's the only thing that will give you 0 on the bottom? Remember, you cannot divide by 0. So if x is 3, then you will be dividing by 0. So therefore, the domain means x cannot be 3. So this is the lazy way to write it, which is fine for now. Then there is something called interval notation. Interval notation means this. You can have everything except for the number 3. So there is a hole in the number 3. So therefore, all of this is fine, and all of this is fine. So how do you write all of that? This is minus infinity to 3, or 3 to infinity. Remember that if there is a hole, you need to use a parenthesis. If it is closed, it's a bracket. Okay? You should remember that too. So therefore, this is the quick way to write the domain. This is the more proper way to write it. So it depends on how they ask you. You need to know that the two are the same. Actually, this, and this is the exact same thing. All right. So now, what about this one? And does the x minus 4 affects the domain? And the answer is no. You only worry about the numerator cannot be 0. That's the only thing you have to worry about. Okay? So therefore, what you do is, well, you're going to need factoring. You set it equals to 0. And if we factor this is what you have. So this will be 0 when x is 0 and when x is 3. Since those are the two values that give you 0, that means the domain is everything except for x cannot be 0 and x cannot be 3. Those are the two restrictions. Okay? So then you do the graph, and you do the same thing. In this case, you should always use 0 for reference, but in this case, 0 is not part of the domain, and also 3 is not part of the domain. Everything else is part of the domain. This, and that. Okay? So therefore, to write this in interval notation, this will go from minus infinity to 0, or 0 to 3, or 3 to infinity. You can see how this is way more annoying, but that's the proper way to write. All right, now here's a slightly tricky question. What do you think is the domain for part C? Are you dividing by anything? No. Are you taking square root? No. So therefore there is no restriction. The domain is everything, minus infinity to infinity. So this is the best case that can happen. If you have a polynomial, the domain is always everything, unless it's a word problem and it restricts the domain at some point. Now, this one, part D, is the first one where we have a radical. So remember what is the issue with the radicals? Just got to make sure that the inside is positive, okay? That's it. So therefore, how much is this? You solve for this. That means subtract a from both sides. Divide by -4. And x is what, less than equals to 2. Then do the graph. Remember, 0 for reference. 2 is here. This one is a bracket, or you can use a closed circle. Goes this way. So in interval notation, this is minus infinity to 2. By the way, when it comes to interval notation, you should make a note of this too. For interval notation, the smallest number always goes first, and the biggest goes second, okay? So you're going to minus infinity, there's nothing smaller than minus infinity, so it has to go first. If you go to the right, there's nothing bigger than infinity, so it has to be that one. Now, the worst case scenario for these domain problems is going to be where you have the two issues. What are the two issues? You cannot divide by 0. And what else? You cannot take square roots, okay? So that will be the next problem. So let's take care of the denominator first. So if you factor the bottom, this is x minus 5 and x plus 1. We're going to do factoring next week. Factoring is also very, very, very important. So when is this equals to 0? If x is what, 5, and if x equals to what, -1, right? So therefore, for now, if you do a graph, what are the only two numbers that are not allowed? You can have what? -1, and you can have 5. Okay? Why? Because you are dividing by 0. Okay? So if I take out the square root, look, this is very important. Look, pay attention to this. If the square root was not here, then the domain is just x can be -1 and can be 5, and you're done. But because you have the square root, that messes everything up, because now you have to make sure that the inside is positive, okay? So that changes everything. So therefore, you also need x minus 4 to be greater or equals to 0, which means x has to be greater or equals to 4. And if you put that information into this graph, remember that 4 is here. So greater or equals to 4 is going to be with a bracket. It's going to be this, or a closed circle. So what will happen then if you bring the red line to the blue line? They will intersect here, right? Here and here. So therefore, this is going to be now the domain. So therefore, the domain is going to go from 4 to 5, bracket and parentheses, and then 5 to infinity. And this is as hard as this gets when you have to combine the two. Okay? Also, okay, this is the part where many people have issues. So just make a note of this. Look, here it is. Let's say you have, I'm going to have two cases, f of x equals to x minus 4. And the second case, f of x equals to 1 over x minus 4. We already did the domain for the first one. What will the domain for the first one be? What is it? It's this one right here. X is what? Greater or equals to 4, right? And then you were going to do the graph. This is 0. This is 4. So it's this. So it's 4 to infinity. What do you think is going to be the difference between this one and that one? Well, this is like you have two issues in one. What are the two issues? This has to be positive, and also it's on the bottom. Because it's on the bottom, it cannot be 0. When it's on the top, it's okay to be 0, so it has the equal sign. But it's on the bottom, it cannot have 0. So you have to be very careful with that, because that's the part where many people miss the problem. If you're going to solve the problem, they're exactly the same, except for one thing that makes a huge difference. Here, this will be greater than 4, which means you cannot have the equal sign. So when you do the graph, they are the same except for what? One is a parenthesis, and the other one is a bracket. And that changes everything, okay? So make sure that you understand the difference between the two, because you're going to see brackets and parentheses the whole semester.